The ocean feels familiar from the surface. Satellites watch it. Ships cross it every day. Yet, beneath the waves, the ocean behaves in ways that still confuse science. Objects disappear. Sounds travel across entire ocean basins. Water flows like rivers without air. And environments exist that look impossible. So what is really happening beneath the surface? One of the most famous ocean mysteries is the Bermuda Triangle. Why is the Bermuda Triangle considered mysterious? For decades, reports described ships and aircraft disappearing within this region of the Atlantic Ocean. Stories spoke of compass failures, sudden storms, and vessels vanishing without a trace. Scientifically, the region lies along some of the busiest shipping and flight routes in the world. High traffic alone increases the number of accidents, but geography and physics amplify the risk. The powerful Gulf Stream flows through the area, moving faster than most ocean currents. When accidents occur, debris can be carried far from the original site in a short time, making recovery difficult. Weather systems in the region can also change rapidly, producing intense squalls and steep waves with little warning. Before modern satellite navigation, sailors relied on stars, magnetic compasses, and estimated positions. Cloud cover, rough seas, and human error could easily compound into disaster. When wreckage sinks into deep water and evidence disappears, uncertainty fills the gaps. And uncertainty is where mystery thrives. Listening to the ocean reveals even stranger phenomena. Why are strange sounds recorded underwater? Water transmits sound far more efficiently than air. Because of temperature, pressure, and salinity gradients, the ocean forms natural sound channels that bend and trap sound waves. One such layer allows low-frequency sounds to travel thousands of kilometers with little loss of energy. This means a sound generated in one part of the ocean can be detected far away. Many recorded sounds originate from natural sources. Earthquakes and underwater volcanoes release low-frequency energy. Shifting ice produces sharp cracks and groans. Large whales communicate using deep calls that propagate across entire ocean basins. Some sounds are created by tiny creatures. Pistol shrimp snap their claws, forming collapsing bubbles that produce loud pops. Millions of these snaps combine into a constant background noise. A small number of recordings remain difficult to identify, not because they defy science, but because pinpointing sound sources in a moving, refractive medium is extremely challenging. Time itself behaves differently in the deep ocean. Why can shipwrecks be preserved so well beneath the sea? At great depths, temperatures are near freezing, slowing chemical reactions. Oxygen levels are low, reducing oxidation and decay. Sunlight never reaches these depths, preventing biological growth that accelerates decomposition. Wave energy decreases rapidly with depth, leaving wrecks undisturbed by surface motion. Without human interference, these conditions allow ships to remain intact for centuries. However, preservation is not absolute. Specialized bacteria can consume iron and slowly break down metal structures. The deep ocean does not stop decay. It dramatically slows it. Sometimes mystery rises to the surface itself. Why does seawater change color in certain places? Color changes occur when the balance of light absorption and scattering shifts. Large blooms of microscopic algae can turn water green or red by reflecting specific wavelengths of light. Storms and currents can suspend sediment, making water appear brown or milky. In rare cases, chemical reactions or bioluminescent bacteria create glowing or pale seas. From above, these changes appear sudden and unnatural, but they are visible signals of dynamic processes happening below. Even when nothing unusual is visible, the ocean continues to make noise. Why does the ocean itself seem to produce strange sounds? Waves interacting with one another generate constant low-frequency vibrations. Pressure changes and shifting currents release energy as sound. The seafloor responds to wave motion, producing microseisms, subtle vibrations that can be detected worldwide. Human activity adds to the soundscape. Ships, propellers, and sonar systems contribute continuous noise. The ocean is not silent because it is never still. Some mysteries appear almost too precise to be natural. Why do perfectly circular sand patterns exist on the seafloor? In many cases, these patterns are biological in origin. Certain fish create symmetrical sand structures as part of mating behavior. Their movements interact with gentle currents, amplifying the geometry. In other cases, water flow organizes loose sediment into repeating shapes. When flow speed and grain size reach stable conditions, circular patterns naturally emerge. Nature does not need design. Physics and time are enough. Some discoveries challenge our understanding of water itself. Why are there saltwater lakes on the ocean floor? These lakes form from extremely salty water, known as brine. Salt dissolves from underground deposits and accumulates in depressions on the seafloor. Because brine is denser than normal seawater, it sinks and remains separated, forming distinct pools. The boundary between the two fluids bends light, creating the illusion of shorelines and waves. These lakes can be chemically hostile, lacking oxygen or containing toxic compounds. To nearby animals, they are deadly traps, underwater landscapes with familiar shapes but lethal chemistry. Sometimes, entire rivers appear to flow beneath the sea. Why are there rivers flowing along the ocean floor? These flows are driven by density differences rather than gravity alone. Currents loaded with sediment or salt become heavier than surrounding water and sink. Once on the seafloor, they flow downhill, carving channels and transporting material across vast distances. These turbidity currents shape underwater canyons and deposit enormous sediment fans. They behave like rivers on land despite the absence of air. All of these phenomena point toward a larger truth. Why does the ocean contain nearly 95% of Earth's living space? Life is not defined by surface area, but by volume. While life on land occupies a thin layer near the surface, the ocean extends downward for kilometers. This creates a three-dimensional habitat with multiple layers, each defined by light, pressure, temperature, and chemistry. From the sunlit surface to the deepest trenches, the ocean offers more space for life than all land combined. Within this vast space, evolution follows extreme paths. Why do giant creatures live in the deep ocean? Cold temperatures slow metabolism, allowing some organisms to grow over long lifespans. High pressure reshapes biological structures rather than destroying them. In environments where food arrives unpredictably, large size can provide advantages in energy storage and movement. Not all deep-sea creatures are giants, but extreme conditions allow extreme strategies to emerge. The deep ocean is not empty. It is active, complex, and largely unexplored. Each mystery we solve reveals several more beneath it. And perhaps the greatest mystery of the ocean is not what it hides, but how much remains beyond our reach.